Hello, welcome to lecture 2 of mechanics of materials. Let us discuss about stress and strain. In the previous lectures we have seen introduction, classification, deformable body and rigid body comparison, etc. So what is a stress? Let me consider a body as shown in the figure here, on which forces are acting as shown. It's a prismatic bar having either a square cross section or rectangle cross section. Even circular or some other cross section is also fine. Let me consider a cross section which is shown by A. It's a cutting plane which is passing through the mid of that body. The body is in, as far as consideration is made, the body is in equilibrium state. Though the forces are acting, they are equal and opposite, the body is in equilibrium state. Now, let me consider the top half and bottom half of the body where the section plane passes through. If I consider the top half alone, it is also in equilibrium. If I consider the bottom half, it is also in equilibrium. So that means for the force F which is on the top half of the body, for the force F which is acting upwards, there must be some force acting downwards on the other face. Similarly, for the bottom half of the body, the force F is acting downwards, for which to have equilibrium there must be equal and opposite force as shown in the picture with some red lines. So this is what is a state of stress. So how do we define stress? Even in the other picture also, a 2D representation also you can see, there is a XX cross section, bottom half of the body is considered, a load P is acting on it. There must be an equal and opposite force so that the body will be in equilibrium. Right. Now, how do we define stress? Stress is the internal resistance offered by the body for the external load applied. Alright. So, this is what, when the load is perpendicular to the cross section, we call it as normal. The stress developed, whatever we call normal stress. There are two kinds of stress in normal. See, one is the tensile stress and the other one is compressive stress. In the tensile stress, the length of the member, length of the object will increase after some time. Whereas in the compressive stress, the member will shorten its length. Okay, so when the load acting is perpendicular to the cross section, when the stress developed is perpendicular to the cross section, we call it as normal stress. When the stress developed is parallel to the cross section, then we call it as shear stress or tangential stress. Here there is an example. You can see there are two sheets joined by riveting. So when you take a cross section at this junction, you can see the second picture. The loads are acting as shown on the upper sheet and the lower sheet. At the point of joining on the rivet, you can see the shear stress developed. Okay. There is another picture, a bolt which is acted on a shear stress is acting on a bolt, the damaged bolt, failure of the bolt is shown. Another kind of category is bending stress, usually on beams. When the load is applied, they tend to take the transverse load and they bend, which is shown in the picture. So the other classifications are twisting or torsional stress. Again, it is shown when a shaft is twisted, the torque is applied on opposite ends, opposite directions as well. The stress developed we call torsional stress or twisting stress. There is another also classification, bearing stress. Let us learn somewhere in the later stage about it. Then let us learn about a strain. The general definition of a strain is change in dimension. It is a ratio of change in dimension to the original dimension. When the force applied is a tensile force, then the strain developed is a tensile stress. When the force applied is a compressive stress, then the strain developed is compressive strain. Or else there is another case when the block is subjected to a surface force is parallel to this surface, the block will change its shape as shown in the figure. So this kind of a strain is called shear strain. The force is parallel to the surface, the shear stress is parallel to the surface. Okay. So this is about stress and strain. Let us see few of the structural members, components which are used for which the mechanics of materials is applicable. So tension and compression members, they are the members on which tension force, tensor stress is developed, the compression stress is developed. Then beams, you can see in the picture here, these are the beam structures. Then there are trusses, you can see here in the picture. Then there are arches, you can see in the picture. Plates, cables, rigid frames. There are two types, 2D as well as 3D it is shown, and shells. Grid I have not shown here, you can just Google. You can also find, just search information in Google and you can find what are the other applications of these members, where are the other components you can find either in the machinery or in the structure or in any other form of structural member. Thank you.